Now, let's begin with question number 6. Question number 6 is about light. 6a. Figure 6.1 shows a ray of light incident on the surface of a glass block. On figure 6.1, accurately draw the reflected ray. Before we draw the reflected ray, first we have to draw the normal line. The normal line must be drawn perpendicular to the surface of the glass block. So this must form a 90 degrees angle. After you draw the normal line, usually we draw normal line using a dashed line like this. Then measure the angle between the incident ray and the normal line. The angle is called the incident angle or angle of incidence. In reflection, the angle of incidence must be equal to the angle of reflection. So after you measure the angle of incidence here, make sure you use your protractor. Then measure another angle over here which exactly equal to this angle. After you measure the other angle, you can draw the reflected ray. And this angle is the angle of reflection equals to the angle of incidence. So the violet line here is the reflected ray. Question 6b. Figure 6.1 shows a ray of light incident on a glass prism. Put one tick only in each line of the table to indicate which of the angles labeled in figure 6.2 are the angle of incidence and the angle of refraction. Guys, this line is the incident ray and that line is the refracted ray. The angle of incidence is the angle between the incident ray and the normal line. So in this drawing, the angle represents by phi. So let's put tick angle of incidence on phi. Angle of refraction is the angle between the normal line and the refracted ray. So in this drawing, the angle represents by this, which is y. So let's put one tick on angle of refraction at y. This is the answer. Angle of incidence phi, angle of refraction y. Next question. The refractive index of water is 1.33. A ray of light passes from water into air. The angle of incidence at the water-air interface is 30 degrees. Calculate the angle of refraction. To calculate the angle of refraction, use this equation. N2 over N1 equals to sine I over sine R. I is the angle of incidence, R is the angle of refraction, N2 is the refractive index of the second medium, N1 is the refractive index of the first medium. The light passes from water into air. So air is the second medium and water is the first medium. Remember, the refractive index of air is 1. So N2 equals to 1 and N1 equals to 1.33 equals to sine of 30 degrees over sine R. This gives us sine R equals to 1.33 times sine of 30 degrees. Do the cross multiplication. Now, sine R equals to 1.33 times the value of sine 30 degrees equals to 0.5. You can use your calculator to find this value. Times 0.5. To find the value of R, use the inverse of the sine. So R equals to inverse sine of 1.33 times 0.5. Use your calculator. On the calculator, you have to type exactly like this. Don't forget the brackets. Then the answer is 41.68 degrees. Now guys, be careful. You have to consider the number of significant figure. The angle of incidence only consists of 2 significant figures. So, the answer should be round off into 41.7 or 42 degrees. You can use either answer because usually we can use one significant figure more than the significant figure used in the problem. So angle of refraction equals to 41.7 degrees or 42 degrees. The last question for number 6. Figure 6.3 shows rays of violet and red light incident on a prism. The dashed line shows the path taken by the ray of violet light in the prism. On figure 6.3, draw and label the path that the ray of red light takes in the prism. A calculation is not required. First, I will replace the dashed line with a violet dashed line to clearly show the path taken by the ray of violet light. Like this. Then, let's extend the path taken by the ray of light when there is no refraction. Like that. Because the ray of light pass through 2 different mediums, refraction happens. The ray of lights will be bent closer to normal lines since the glass prism has larger refractive index compared to the air. So, let's draw the normal line first. This is the normal line. Remember, the normal line must be perpendicular to the surface of the prism at the point where the ray of light strikes. So, this must be a right angle, 90 degrees. Violet and red lights have different wavelengths. In this case, the refraction depends on the wavelength. The shorter the wavelength, the more the ray of light will be bent. Once again, the shorter the wavelength, the more the ray of light will be bent. Violet light has shorter wavelength than the red light. Therefore, violet light will be bent farther than the red light. So the path of the red light will be slightly above the violet light. This is the violet light. The red light must be drawn slightly above the violet light because, once again, the violet light has shorter wavelength and therefore will be bent further from the real path of the ray of light. So our red light will be drawn in this position. It is still bent closer to normal, but slightly above the violet light.